get quickly started off. So good morning. Thank you for coming over to this quick session. It's going to be about 15-20 minutes. It's going to include a demo, mostly technical, about how we implemented a couple of demos that we created for this conference. My name is Chanakya Lokam. I'm the Director for Innovation at Microsoft, which is a business partner of IBM. We have a lot of demos set up at our booth as well, so if you'd like to come by and check it out, we're at 729 on the concourse. It opens at 5 o'clock today. This was kind of an ad hoc session. I actually have a more scheduled session tomorrow that got approved, but this is kind of a piece of that. So if you want to attend that, you can attend that tomorrow at the Micro Theater. But basically, I just wanted to talk a bit about how we were using OpenWhisk and what you can basically do with it. So it's going to be talking a bit about serverless and how you can actually use Watson in these serverless use cases. So that's kind of the overview of the session that we're going to cover today. So a quick agenda. I'll quickly introduce you to serverless and OpenWhisk. After that, we'll understand the use cases that we built, and I'll also show you the demo as well. So just to take you through a quick overview of kind of the evolution or the revolution or whatever you want to call it, of how we moved over. You all know the story. We moved over to physical, then virtualization with VMs, and then we slowly moved on to the cloud, and then they started talking about containers. So it's always changing. So I was kind of confused when I was putting together the slide of what flat icon to use for serverless. I thought of leaving it maybe empty, but I finally decided on putting kind of a transparent thing or a translucent thing for serverless. So the fact is that right now the whole intention or the driving force behind trying to move towards containers or serverless are scalability, microservices, and all of those, but also one of the major things is making sure that we can make life easier or make life more fun for the developers that are actually creating these applications. So serverless, also known as, this is what is there on Wikipedia, also known as functions as a service, is basically the model where you don't have to worry about serverless. You still have servers, they're actually being run on containers in the back end, but you still have infrastructure running, but basically you don't have to worry about it, or the developers who are creating these actions or functions or these services, they don't have to really worry about provisioning stuff, scaling stuff, and all those sorts of things. So OpenWhisk, some of you might already know about it, was released February 2016 in beta. December 2016 it got GA'd as well, so it's now generally available on Bluemix. It's an open source project. It's part of the Apache projects. And it basically is it's actually the first serverless open source platform, and it basically allows you to create these small functions, which they call as actions, chain them together in something called sequences. You can also write rules and triggers as well. So if you wanted to trigger an action based on a particular event, like maybe clean up a database when a new record is stored, or whenever a message is put into a queue, you can do those sorts of things. So it's basically event-driven, but at the same time, you can also make REST calls, and we'll talk about that in a minute. So just to talk a bit about the developer experience when you're working with OpenWhisk, whether it's on Bluemix or whether you want to deploy it somewhere else. There's a multitude of languages supported. Node.js is what I'll be showing to you today, but there's Python, Swift, there's Java as well. And if there's a language that is not supported that you want to deploy, you can also put it into a Docker container and deploy it onto OpenWhisk as well. So that option is available also. So just to talk a bit about what the experience from a developer perspective of creating these services is, if you were to deploy OpenWhisk on something like your laptop or anywhere else that you wanted, you can deploy it on OpenStack as well. You can basically use the CLI tool, which is the Whisk CLI. At the same time, you can also create these services using the UI, which is available in Bluemix as well. It's very intuitive. You just put your code together, name any dependencies, environment variables, and you hit make it live, and it goes, boom, it's available. It also supports the delivery tool chains, which are available within Bluemix. So if you wanted to continuously deliver your services to the cloud, you can do that as well. You can build these tool chains where you just push your code to GitHub, and they will get deployed. That also uses the Whisk tool CLI as well to deploy them. So that's another option when you're delivering these services. Right now, with this particular demo, we exposed some of the services as managed APIs as well. Previously, we had to take these APIs from the OpenWhisk gateway, as it was called, and put them into API Connect. As of today or at this conference, I don't know if it was released yet, but if you checked out Bluemix, API Connect is now natively supported within the OpenWhisk platform as well, so you don't have to go out and create these managed APIs. From within the OpenWhisk platform, you can actually create these managed APIs where you can put stuff like throttling, security, and stuff like that on top of your OpenWhisk services, if you want to expose them as REST. So just a couple of properties of serverless services, and this doesn't only apply to OpenWhisk. It could be any of the other platforms like Iron.io, AWS Lambda, and others as well. So you can expose them, basically calling them out from your applications or consuming them. You could consume them through a REST interface. You can also do that through event-driven, and that's where most of the use cases are. And the reason why that is being seen is we're seeing a lot of the use cases where we previously used to use stuff like web workers and clustering and child processes. We're now seeing serverless services actually come in and be used in that particular use cases. So as you know, most of these services within OpenWhisk or the platform are very short running. The default time is 60 seconds for it to live. You can increase or decrease that, but most of the use cases that we're looking at will be use cases that are below a second. So we're all talking about millisecond services that are rapidly being created and killed. All of them are stateless, as you know. They just do what they're told to do, and then they're gone. They don't remember what happened before them or what's going to happen after them. They just take in a JSON input. They process that, do what you want them to do. They give out a JSON input, and they're done with it. Also, the way that you want to build it, it's not that they are narrowly focused. You could put the entire web server logic into one, but that wouldn't be advisable. The way or the best practice that you would want to follow when you're creating these serverless services would be to make sure that they're very focused on doing one particular thing so that you can reuse that, and I'll be talking about that in a minute. So a couple of use cases that we're seeing from a lot of people who are already using serverless, and this is not something that is new or brand, it's something that has been there for about a year or two right now, and a lot of customers are actually running serverless services in production as well. So cloud automation is one particular thing. So if an instance dies, you might have to do some sort of cleanup, recreate another instance, maybe configure it in a particular way. Especially with cloud APIs being exposed in the public cloud, you can have these serverless actions actually do that sort of thing. Obviously, backends for web and mobile, and actually chatbots as well. And I'll be talking about a chatbot in a minute. But we're seeing a lot of these, especially with frameworks like Angular and React coming on the server on the client side. We're seeing a lot of these backends move over to serverless because you don't want them to run forever. If nobody's using your app at night, why even run it on the server? Media and data processing is another thing we're seeing a lot, especially when the load peaks and goes down. It wouldn't be analytics that you're looking at in terms of media and data processing. It's more of the ETL kind of loads where you're trying to stream data into a data store. That's where we're seeing a lot, whether it's a NoSQL database, something like Hadoop, or object storage, which we'll be talking about in a minute. So we created a quick demo of an image processing pipeline, and I'll talk quickly to you about the architecture and what is there within the demo. So basically, we for the session that I have tomorrow, I wanted to talk about what you could do with a delegate model where you would put something into a queue and ask somebody to do it for you so that the user doesn't have to wait. And image processing is one of the things that we're seeing serverless being used for a lot. So one of the major issues with images are they're large, they're small, they take time to process. So if you were to build an application which is dependent on images, where you had to maybe do visual recognition or image compression or quality adjustment and stuff like that, usually that's going to take time on the server, and it might be, and I'll show you the times that it took for us, but it might be a second or two. And when you actually look at a second or two, it might seem like a short time, but if you're actually the user who's using it, that's a lot of time to wait for something to respond back to you. So basically what happens in this particular architecture is a user selects an image, he can take any image that he wants, he can post it to the server takes that, and while it's storing it into object storage, it also triggers a topic within Message Hub, which is a Kafka-based offering on Bluemix. we actually post the message or publish the message into that topic. That is consumed by our sequence within OpenWhisk. OpenWhisk supports a lot of triggers that are already enabled, like Message Hub is one, Watson IoT is one. So these are already enabled within OpenWhisk, so you don't have to actually create these feeds or triggers within the platform. You just configure them for use. So once it comes into OpenWhisk, the sequence compresses that image. It's actually coming into it in a stream format. It converts the format. It then sends it to Watson Visual Recognition. It recognizes the data, brings back the results, takes the top result, and stores it into the object storage once again as metadata. And that particular data is then taken back and it's sent to the user as a Twilio text. That's the reason why my phone is making so much noise. I wanted to keep it on. So that's kind of the architecture, and that's what's happening, and I'll show that to you in just a second. But before we even see the demo, just exploring what it means in terms of times, in terms of money, about serverless. So this was kind of some of the statistics that we collected from our sequence that we created within OpenWhisk, and kind of looking at what times it was taking. So we had 4 actions within the sequence in OpenWhisk. The first one was to retrieve the message from Message Hub. Second one to actually process the image with Watson Visual Recognition. The third one for updating the object store, and the fourth one for sending the text via Twilio. So if you look at the times, the overall time of the entire pipeline took about 5 to 5.7 seconds to respond back, which is a lot of time. Believe me, if you're waiting on your phone looking for that image to come back, it's a lot of time. And if you take a look at the costs that you would incur, and we didn't look at a VM, we looked at the Node.js runtime on Bluemix. So the costs of running this for 1 week for 50,000 images. So if you were to run this sequence 50,000 times over, it would cost you 93 cents across 1 week. In OpenWhisk, it doesn't matter time, but 50,000 executions would be 93 cents for you. Versus if we were to assume that 50,000 images were being processed across 1 week of time, that's 7 days, it would cost you approximately $23 if you were to run an actual server or a Node.js runtime, which is still very lightweight, but still the cost difference is almost 23x. Now, as you increase the numbers, that will become even more better. Now, if you were to look at a use case where your server has to continuously listen to something, or it has to be long running, it has to run for more than 60 seconds to process data, this would be a very bad use case to not use serverless for that. Serverless would be used for all those microservice, those millisecond-based use cases where you have to respond back very quickly. So I'll quickly show the demo also to you. So we built a small app in Ionic. So you can see on the right for you as well, sorry. So you can see the mobile app that we built. It's just a hybrid app built in Ionic. So basically it takes the images, changes it over to base64, sends it over to Node server. The Node server posts it into object store, and you can also send the Message Hub or publish the message to the topic in Message Hub through the Node server as well. And that's where the OpenWhisk sequence is triggered. The one that you see on the left is the OpenWhisk monitoring dashboard. So you can see what actions were called, how much time did they take, what was the time that it took to process, was the result successful or not, and stuff like that. So I'm just going to go ahead and add an image. So I have a couple of images already that I had, so I'll just show those to you rather than take a picture. So we have Superman, and I can go ahead and upload the image. So the image was uploaded. You can see right now, most probably the action is already happening. We should receive a message in a second. So that's the message. So you can see your image classification has been updated. That's coming through Twilio. And if you go back, you can see right now it's saying processing, but if I refresh it, you can see it's image classified. And right now, as I was saying, you can see that it does take a bit of a while. Just because you're not seeing anything saying that you have to wait, you're not thinking that it's taking a long time. But believe me, if you had like a pop-up saying it's processing, you have to wait, it would take a lot of time. You would actually understand that 5 seconds is a lot of time for a user to wait. And right now, this demo is just showing one image. If you were to actually look at 50,000 users uploading 10 images each at the same time, that would be when the solution would be able to scale out. You don't have to actually look at what sort of scalability is enabled within OpenWhisk. It will scale on its own. You just have to pay for it. You don't have to worry about which server is running, which server is not. You don't have to worry about the state of the servers and stuff like that. Everything is handled on its own. So this is where you can see all the logs. I believe you can also take this into the Elk stack and check it out over there as well. So just to finish up the session quickly. So, give me a second, I'll put this inside. We're done with that. It served its purpose. Okay, so this is another quick demo that we created. We changed the names, but it's actually a production implementation that we're working on right now. I can't put that, I'm not at liberty to. But this is another quick demo that we have. This demo is actually running at our booth if you want to check it out today evening or tomorrow. And it's called ThinkChat. And basically, we were playing around a lot within our labs team with drones and stuff like that, and that didn't end up well. We broke a lot of things. But basically, what we were trying to do was control these remote devices from wherever we are in the world using MQTT. So a couple of months ago, we attended this event called Digital Summit, and we wanted to kind of showcase how we could do the same thing but with a chatbot interface, right? So we didn't want to actually send a command or press a button. We wanted to talk with these devices, say, fly a drone, or can you turn on the light? Natural language, basically. So this is a Watson-based use case. It uses Watson IoT and the Watson Conversation Service. It's an Ionic-based mobile app that we have at the front end. We have Facebook Messenger connected as well. And the challenge that we had when we were building this was that creating a node server or any server to handle all these channels was becoming very costly, because what we were seeing was that if a user is using Facebook, he would not be using Twilio at the same time. He would not be using the mobile app at the same time. So they would only be using one channel. But when we were using a node server, we were actually running the server across all 3 channels all the time. So what we basically did is we decomposed the entire node server, and the one that we built for December for the other event was actually a node server. So we decomposed the whole thing into these smaller services that were very channel specific on one side, and some that were very generic that all the channels were using. So you can see we have all those different services that we built out over there. I think there's 11 total. So basically what's happening over here is a user can send a message through any channel. Based on what channel it's coming through, it goes through our API gateway, which is API Connect in this case. The reason why we used API Connect was to enable that layer of security on the managed APIs because it's being exposed to so many channels. And basically what happens is that based on what channel it's coming through, that only that sequence of functions is run. So if it's coming through Facebook, the response mobile or the process Twilio data or the response Twilio, none of those are going to be called. At the same case, if you know about Watson Conversation, you have to initialize a conversation for the first time when you're talking with a specific user. And that service is also something that is only called once in a lifetime of a user. So if you were connecting through a Facebook channel and you were chatting with a bot for 1 year, that service would only run once. And you don't have to run it for 1 year on a node server. That's totally a waste of money. That's throwing away money. So some of those services are only running when they're needed, versus others are scaling up a lot more. We have another couple of services here at the bottom, if you can see, called log conversations. So we're logging all the conversations that are coming through. So that's another one. And what we wanted to do is, since we didn't want the user to wait while it's being logged, we made that as a delegated worker once again. So it's we have messages being placed into Message Hub, and log conversations is taking that and logging into the database. The same thing we have with the MQTT piece, but at the bottom as well. If you like, we actually built this with Legos as well. So if you're into Legos, you can come and check that out at the booth. We have that full demo running. So just to finish off, you can see these are all the services that we use in this particular implementation. The ones in the light blue are the ones that are being used by Facebook. The red are Twilio. The darkish blue is the one that is being used by all the channels, and the gray ones are the ones that are being delegated as workers. So all of these are, they don't know about each other, they don't care about each other, they don't talk with each other. The only way that they communicate is using JSON, and they're all connected by the OpenWhisk platform, which is building them up or chaining them together as a sequence. So with that being said, thank you so much for patiently listening to me. We have another couple of sessions, as I said, across the conference if you want to attend. You can also check out those sessions at miraclesoft.com/IC.